So let's come back and do the 17th question of your CBSE board paper, that is 2018 and 19. Right. When I come back to 17th question, so let's see this. Here, complete the following questions are quite common in section C. Remember that. Right. So here they've given us this. Okay. Then. And they've given us hydroxylamine. So simple. Whenever you see such reactions, hydroxylamine, or you're taking semi-carbazone, reactions of aldehydes and ketones, very simple, nothing to remember. You have to just take out water molecule from here, okay, minus H2O, and directly write the compound. Nothing to change. You're not going to change any bonds and anything. Just write the compound. Double bond is here, NOH. Simple, isn't it? Now, so when I come back to this, so what is important? What should you remember here? KMnO4 is an oxidizing agent. Remember that. So whenever you're taking cyclohexene, important. This is a different reaction, right? So here they picked up that reaction, but as such, whenever KMnO4, that is acidified KMnO4 is there, it is an oxidizing agent. But here, what is it going to do? It's going to break up this bond here. It will break up, and it's going to form a compound. Means it's going to add carboxylic acid, because it's acidic medium we have taken, isn't it? It's going to add carboxylic acid on both the ends. You have a carboxylic acid just like this only. It's going to add, but what is important is it's going to form a straight chain and here, right? So what is the role of KMnO4? Here, your concentrated KMnO4, that is an acidified KMnO4, it leads to cleavage of bonds. Remember that. Of bonds, and also acts as oxidizing agent. So what does it do? It's going to add COOH on one end, COOH on other end. But how many carbons do we have here? You see here 1, 2, 3, 4, 5, 6, isn't it? So just let's write. This is 1. Already this is 2. This is the third one. This is the fourth one. This is the fifth one. This is the sixth one. Okay, I have made it a smaller chain. Join it here. Okay, that means how does this look? This looks like COH group on one side, then CH2, one more CH2, one more CH2, COH. Okay, total number of 6 carbons. 1, 2, 3, 4, 5, 6. This is the answer, right? So now, when I take the next question, what are you saying? What is here given? What important thing should you observe here? Here they have given this reaction or this particular thing. No, it is nothing but Gabriel phthalimide synthesis. Right, so Gabriel phthalimide synthesis, how is it given, ma'am? How is it prepared? So let's see the whole reaction and then come back to this in the presence of ammonia, right? Okay, this is an intermediate given to us. So first important thing when I take, I'll be taking this phthalic acid. This is something that I said Gabriel phthalimide synthesis. Take this phthalic acid first. You're going to add ammonia. Then what does it form? It's going to form a compound which is in equilibrium with. This is going to form an intermediate first. Then you get added to this. This becomes COO NH4 plus and COO NH4 plus. But this is called ammonium phthalate. This is phthalic acid. This is ammonium phthalate. Then further what happens? This ammonium phthalate, when you're further heating it, it's going to form a compound called phthalimide. Remember that. Okay, this is ammonium phthalate that is done. Further, when I heat this, it's going to lose this hydrogen from here, and you're going to get this is CONH2 or NH2. Okay, right. Now further, when you heat this, now what are you going to do? You're going to do here you're heating it and removing 2 water molecules. That is what see here, H2O, 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 H2O. So you got this. Now what are you going to do? You're going to do strong heating here. Then finally you're going to get a compound. See here, there is a cleavage. Yeah, let's see here exactly. CO is retained here, N and H is retained, and NH3 is out. So I get a final product, that is with your C double bond O, this also C double bond O, and what is the compound? NH. Okay, this compound, this is called phthalimide. This is the answer. So hope students this is clear. Phthalic acid plus ammonia, it's going to add around these two hydrogens and you get this intermediate product. This one heating, it loses, what is it doing? It's going to form phthalimide, isn't it? Right? So here what is happening? This one is not here, it is not losing a water molecule. Here it is losing two water molecules. Further on strong heating, ammonia is out and finally phthalimide you get. So this is a compound. Done. So let's see the next question. What do they give me here? Give reasons for the following. Use of aspartame as an artificial sweetener is limited to cold foods only. What is the reason they said? Right. So first of all, whenever such reasoning questions are given to you, remember, instead of writing a direct answer, you have to be a bit careful in answering. Aspartame. What is the speciality of aspartame? See here. They said use of aspartame. That means if I use aspartame as an artificial, means aspartame is used in artificial sweetener, it is limited to cold foods. Means only cold foods only I can use aspartame. I can't use it in hot foods. What will happen when I use it in hot foods? That is the question. Right. What should you remember? First of all, whenever you take aspartame, okay, and when you do, means when it is exposed to high temperature, that means when you heat it, what will happen? This aspartame is going to release a substance, or it's getting converted to a substance called phenylalanine. This phenylalanine is harmful in nature. So this is the reason. Aspartame, which is a non-saccharide sweetener, means a sugar substitute, because it gets converted to a harmful substance at high temperature, it is only, we write this, since aspartame gets converted to phenylalanine high temperature, right, it is limited to cold foods only. Okay, and what is important here, it is a cold foods and is used as artificial sweetener. Okay, till here you have written, but here you are going to add one more point from your side. You will write it as it is non-saccharide sugar. Okay, as it is non-saccharide sweetener or sugar. That's it. You will end off your answer here. So the examiner has a complete analysis. Okay, the student has written about aspartame. The student knows how is it getting converted to your harmful substance. Like that, the examiner will be clear and he'll give you full marks. Done. So from your side, you have added this point and this point. Now, so next thing, what do you give me? Metal hydroxides. Yes, so metal hydroxides are better alternative than sodium bicarbonate for treatment of acidity. So here they said you're taking metal hydroxide, okay, and you're using as an alternative for sodium bicarbonate, where in the treatment of acidity. Why are you not using sodium bicarbonate? Right? So what will happen? Let's see. So basically, when I use excess of sodium, excess of hydrogen carbonate, what will it do? Let's take what actually is this. So that means, suppose they said we are using this, we are not using this. Let us start the reason from here. Bicarbonate, what will happen? Just see this. Bicarbonate is HCO3 minus. When it dissolves in water, what is it going to do? It gets converted to carbonic acid and it is going to release OH minus ions. Done? Yes? Fine. So what is now increasing? Here hydrogen carbonate will make the stomach, means when to reduce acidity, more of OH minuses are released. So what will happen? This will make the stomach alkaline in nature. Correct? So you will write this reaction and say bicarbonates make stomach alkaline in nature because of release of OH minus, alkaline. And what does it do? And triggers, means it will activate the release of what? Triggers the release of acids, release of stomach acid, okay, HCl. So that is the reason we are not using bicarbonates. Now that when I speak about hydroxides, What is the speciality? This I have ruled out. Now when I come back to hydroxides, you can write metal hydroxides. What are the metal hydroxides? Like calcium hydroxide, magnesium hydroxide, you know, all these. Calcium hydroxide, magnesium hydroxide, iron, ferric hydroxide, aluminum hydroxide. You know, they are sparingly soluble. Hydroxides are sparingly soluble, means like very less solubility. And because they don't dissolve, what will happen? They will not increase the pH, isn't it? Correct? So you write metal hydroxides are sparingly soluble or insoluble. Okay, no problem. Insoluble. In which one? Insoluble in water when you put it in the stomach. But bicarbonates are soluble. So because they are insoluble, they do not increase. Insoluble, and hence do not increase the pH. Okay, above neutrality, that means above 7 it will not increase the pH, it will maintain that pH. That's the reason we are using hydroxides, not bicarbonates, because bicarbonates will reduce OH minus here. That is how you are going to do. Right, now these two questions are over. Let's see the next question which they've given us. They've given us aspirin is used in the prevention of heart attacks. Okay, so basically what is the role of aspirin? Aspirin, when I see, it acts as what the main property is, it has an anti-blood clotting action. That is the key word which you have to write. So first you can write aspirin has, we'll put it in inverted commas, anti-blood clot action. It has anti-blood clot action. Okay, right. So this is the keyword. Here only you'll get 1 mark. And because it has this action, what will it do? It will prevent the, it will allow the free flow of blood. Instead of clotting it, instead of forming lumps, what does it do? It allows free flow of blood and prevents heart attack. But this is not suitable for all the patients because it varies with different people mode of action. So you have to be specific and careful. Everybody cannot take aspirin. You have to be specific, and with the doctor's suggestion only aspirin should be taken during heart attack. Done. So these are your questions. Hope this is clear, students. So what did they do in question number, okay, this is your question number 17 which I did these 2 questions. After that, question number 18, they have given 1, 2 and 3 questions. Now, so in question number 19, now let's come back to question number 19. This is the question. So let us write. What do they give me? In question number 19, name the branch chain component of starch. So what is a branch? They asked you to write only name. What is the branch chain component of starch? It is nothing but amylopectin. Okay, nothing they've asked. Branch chain, because we have amylopectin, isn't it? So you have a branching at C1 and C6 carbon. So directly you can write the answer. Branch chain is amylopectin at C1 and C6. What are the next question they've given me? Ribose in RNA and deoxyribose in DNA. Right? So DNA differ in the structure of which carbon? So they directly gave me ribose in RNA and deoxyribose of DNA. Vary in which position? They want you to write only the position, nothing else they want you to write. So simple. Ribose and deoxyribose, where do they differ? Means they differ at C2 position only. It's okay. Simply, instead of if you have very less time, you can finish off writing the answer at C2 position. But for your information, let me draw the DNA and RNA structure. So this is clear for you all, right? So let me start. So when I said it is the DNA and RNA differ at second position, let me first draw DNA structure. So this is your DNA structure. It is written, means you will simply write it as 2-deoxyribose. Why are we writing? Just now I said at the second carbon there is change in, means the second carbon position there is change in the group, right? So when I take RNA, I'm going to again write it as ribose sugar. Now let's see. In both the things, first you have your oxygen, here also oxygen, right? So link it here. So in biomolecules I have shown you how to draw the structures. link it here. Here, this is the first carbon, this is the second carbon, this is the third carbon, this is the fourth carbon, and we get the fifth carbon here. Again 1, this is 2, this is 3, this is 4, fifth you get. In the first carbon, you have attached OH above and H down. Here also in first carbon, OH above and H down. In the second carbon, you have to be careful. This carbon, hydrogen is here, and in deoxyribose, you have hydrogen, both hydrogens. In ribose, you have hydrogen here and OH here. In the third carbon, you have hydrogen here and OH. Here in the third carbon, you have hydrogen and OH. Here in the fourth carbon, you have hydrogen down. Here in the fourth carbon, hydrogen down, and this becomes the fifth carbon now. This is CH2OH. No, this is the fifth carbon. Here also CH2OH. This is the fifth carbon. Okay, hope you understand this. So first carbon, same. Second carbon, this is different. Let us put this in the box, OH. So that's the reason we say deoxyribose and ribose, they differ at which position? They differ at C2 position. That is your answer. Hope this is clear, students. So this is why I have directly written C2 position. Now let's come back and do. Okay, this is done. Let me see A, B. Do we have any question? 19th, there should be a C question, isn't it? Okay, C2 position. Already I have drawn the structure here of this particular thing. Here I have drawn the structure. So this is here represented. Now C2. Then they said how many peptide linkages are present in a tripeptide. It's a direct answer. How many peptide linkages? Basically, when I have to speak about peptide linkages, okay, right? So I don't have place here. I'll be writing the answer for this here. Okay, let me write the answer here for the solution part. What is the answer? Peptide linkage means, first of all, whenever they say peptide linkage, remember one important thing. Nothing like what is important thing? Peptide means C double bond O NH linkages, peptide linkages. Now they said how many linkages, peptide linkages in tripeptide. Tripeptide, simply as the name says, dipeptide means 2 linkages. Tripeptide means 3 linkages. Don't get confused. Like tripeptide means it has 2 peptide linkages. Remember that. Tripeptide is how many? 2 peptide linkages. How, ma'am, how is this? Let me see. Let me show you. Suppose if I take a tripeptide, for example, valine. Okay, let me take valine, glycine. Okay, means I'm just showing it at a stretch, right? So serine, like that, right? So here, when I take one example, this is a tripeptide, isn't it? All are linked together. So first of all, when I draw the structure of this, okay, valine, and let me draw the structure and explain. CH3, hydrogen, NH2, C double bond O, NH. Okay, this is one peptide. This is linked to one more C double bond O, NH, C double bond O, hydrogen, OH. Okay, right? So like this again, this links to one more. This goes on like this, NH. This is CH3. So this is H. This is C double bond O, OH. This is one unit, this is one unit, this is one unit. How many peptide linkages you have here? See here, this is one peptide linkages. This is one more peptide link. So how many did we write? We have written 2 peptide linkages. So in the exam, nothing to write about this, but I am giving you for a tripeptide, the number of linkages is only 2. Done? Yes. So this is your question. Hope this is clear, students. I have done this question. Let me show this to you. What did I do in question number? Now, okay, this is the next question. So I have picked up question number after question number 18. I have picked up question number 19. This is the first question. We have written amylopectin. This is the second question where I have shown you the structure of DNA and RNA. After that, I have turned the page and have done this question, C part, peptide linkages, where I have given the answer here, right? So let's come back and do the next question. That is your question number 20. But here, what do they give me? They have given me in this one only, basically in question 19 an or question. In question 19 only there is an or question. Let's read that. So they said give 3 reactions of glucose which cannot be explained by its straight chain structure.